All right, now we're on vertical motion. This is 1J vertical motion. A rocket fires its engines to launch straight up from rest with an upward acceleration of 5 meters per second for 10 seconds. After this time, the engine shuts off and the rocket falls freely straight back down to Earth's surface. All right. Part A, sketch a graph of the acceleration as a function of time from t0 to t5. Well, it said the acceleration was 5, so the acceleration is 5. That's it. It's always 5. Sketch a graph of the velocity as a function of time. Well, we know on a velocity graph, the slope of the line is equal to the acceleration. So we need to draw a line that has a slope of 5. And so we know that from rest, so the initial velocity is 0, so I really just need one other point. What I need to know is how fast was it going at 10 seconds, and the slope of that line should be 5. So I think it's going to be right here, because I think 50 divided by 10 is 5. But let's make sure that's right. So we need a formula to figure it out. X equals v naught t plus 1/2 at squared. So the initial velocity is 0. Oh, that's the wrong equation. That's for x. I don't want that. I need Vf equals v naught plus at. That's better. So Vf is equal to 5 times 10. 50, yeah. So now I get my ruler, wherever that is. Here it is. All right, so here is my velocity graph. It should look like that. And the slope is 5. From the graph drawn in part B, determine the velocity of the rocket after the initial 10 seconds of travel. Well, that would be 50 meters per second. From the graph drawn in part B, determine the height of the rocket after 10 seconds. What? Oh, so that's going to be the displacement of the graph. It's the displacement of this triangle. So this is 1/2 base, which is 10, times height, which is 50, which is 5 times 50, which is 250 meters. 500, or half of 500. The acceleration of the rocket 10.1 seconds after it launches 0. Because the rocket shut off. No, it's not. It's negative 9.8. Sorry. Not 0. Because it's accelerating due to gravity at that point. Uses the definition of free fall to explain your reasoning for your claim in Part E. Well, in free fall, objects are only experiencing the gravitational field. And the gravitational field is equal to 9.8 meters per second squared. The gravitational acceleration, its symbol is little g. 10.1 seconds after the rocket was launched indicate whether the rocket was moving upward or downward. Well, it was still moving upward, even though the acceleration is downward, right? Because it had a speed of 50 meters per second, and then afterwards it starts slowing down, but it's going to slow down to 49, 48, 47, 46, right? I mean, it's going to keep going up for quite a while until it hits 0 and then starts coming back down. So I will enjoy reading your evidence and supporting your claim, and you can write that. I'll enjoy reading that. You already did that because this assignment is over.